ಶರಣು 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 ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು 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 ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ವಿದ್ಯ ಪ್ರದಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರುತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು 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 ಸಿದ್ಧಿ ವಿನಾಯಕ.
The Honorable Chief Minister of Karnataka, Sri Yediyurappa, we continue with the presentation of the floral bouquets and mementos, and to Dr. Madhavan Nair, former chairman of the Indian Space Research Organization, whom we are also very pleased to welcome here today. Professor B.V. Srikantan, who is professor at the National Institute of Advanced Studies.
Hari Om. Namaskar. Morning. On behalf of the organizing committee, on my personal behalf, I welcome you all the Global Conference on Cosmologies. I extend a very special welcome to the Honorable Chief Minister of Karnataka, Sri Yediyurappa ji, who has graced this occasion by his esteemed presence. He has kindly agreed to inaugurate this event in spite of his schedule and various official commitments. His keen interest and generous support towards the conference cannot be described by words. Sir, it is your enthusiasm and inspiring leadership only that has made Bangalore and Karnataka an attractive place for such efforts. This can be done only by you only.
You may be surprised with my statement. Why do I include vacuum, space and time among the constituents of the universe? You will perhaps understand that at the end of my talk. Why I include vacuum, space and time as constituents of the universe. We normally think it is all matter and radiation, but it's not just that.
ನಮ್ಮನ್ನೆಲ್ಲ ಬೆಳೆಸಿದಂಥ ರಾಷ್ಟ್ರೀಯ ಸ್ವಯಂ ಸೇವಕ ಸಂಘದ ಹಿರಿಯರಾದಂಥ ಸೂರ್ಯನಾರಾಯಣ ರಾವ್ಜಿ, ladies and gentlemen, I am delighted to be here on this great occasion. The beauty of the night sky and the millions of twinkling stars stir the imagination of all of us. It has been so for thousands of years, ever since the dawn of civilization. People in different parts of the world have wondered how and when and for what purpose all this come into being. This thinking has led to the varieties of cosmology in different parts of the globe. In this 3-day conference organized by Sri Srinivasa Jyotishya Vijnan Research Foundation in Bangalore, I see from the program that there is being to be detailed discussions.
Generally, there is an impression that everything has come from the West. Have not the other civilizations also contributed to the human thought? That is the point of discussion today.
Sri Devanath Acharya ji strongly believes that the wealth of knowledge and experience in the field of cosmology and astrophysics, which the Institute has gained over the past few decades, should be shared with the entire world and especially with the younger generation.
Honorable Chief Minister Shri Yedurappaji, Professor Sri Kandan, Shri Acharya, Professor K.V. Acharya, Shri Balaji, Srimati Krishnaveni, Professor Ramamurthy, distinguished delegates, and ladies and gentlemen, a very good morning to all of you. In fact, it's my proud privilege to be here to talk about our moon mission to the conference delegates of the Global Cosmology Meet. Well, I must thank Sri Acharya for giving me this opportunity, and also the Srinivasa Jyotish Vijnan Research Foundation for organizing this mega event lasting for 3 days. At the outset, let me wish all success for the deliberations of this conference. The cosmology is as old as human civilization, and India can be proud that we had great scholars almost 10,000 years back, and the references in Vedic literatures and Puranas are clear indication how deeply our rishis have looked at the universe and then tried to understand the phenomena and decipher the mysteries to a great extent. Looking back, many of the modern findings what we have with very sophisticated instruments clearly coincide with the finding of those Vedic period. How it has become a reality is still a mystery. Whether the power of the mind was so strong to observe even the minutest perturbations which is taking place in the universe and on the globe itself, and how to correlate all this in the form of precise equations. This needs to be researched, and I can see that number of scholars who are specialized in that are here. Well, this is essentially a satellite which is configured to carry a large number of instruments for observing the moon, and it has to be taken from Earth to the moon. The distance, the closest distance is something like 400,000 kilometers, and to travel to that distance has become the first challenge. We had a powerful rocket, the PSLV, which has been a workhorse for all these years, and that can carry something like 2 tons into a geotransfer orbit, that is, with the closest distance of about 200 kilometers and about 20,000 kilometers farthest from the Earth. And we have used this rocket to send communication satellites even up to 36,000 kilometers. And that is all our experience in the past. But now the challenge is to go from Earth to the moon. We should see that the moon is moving, Earth is rotating, and it is influenced by the inertial forces. How to configure a trajectory to achieve this has been the first challenge. Then the second, of course, the spacecraft itself is a very complex one, carrying a large number of instruments, and then that signal has to be transmitted over this distance. So a ground segment which is called a D-Space tracking network is established near Bangalore, a place called Bailalu. A huge antenna of about 32-meter diameter with an active control system and telemetry receiving setup was established for this purpose. Well, I think this the spacecraft is very unique. We configured in such a way that it can cover almost all bands of spectrum, starting from the visible to the IR and to the X-rays and gamma rays. So this is a very unique system which you have conceived. Earlier, there were missions to moon where we had some optical sensors or laser imagers or 1 or 2 instruments at a time. But here, we have assembled 10 instruments, 5 from India and 5 from abroad, and they are put together to carry out this function, and it has become a very unique configuration as far as the objectives are concerned. Next. Well, I think basically, yes, okay. The instruments were used for subsurface chemistry, trying to get the near surface on the top layer, what it looks like, then the mineralogy of the moon, and determining subsurface features using microwave and so on. So we had the microwave, infrared, X-ray, ultraviolet, and gamma ray instruments simultaneously on board. Of course, the findings which came from this was really fantastic. I will touch upon in the subsequent period. But before that, going to the moon itself, there were attempts by other countries in the early times were not very successful. People have attempted, maybe the 6th or 7th attempt they succeeded. So we were to be very cautious. So we tried to move from Earth step by step, and it took about 6 steps before we reached the moon. So the idea is, as we move away from the Earth, the gravitational field of the Earth reduces, but at the same time the influence of the moon, sun, and other nearby planets increase. But we have only a theoretical knowledge of these at the time, and we wanted to calibrate it. By going for the intermediate orbits, we were able to precisely get these coefficients. The net result was we have arrived on the moon with a precision of less than 10 kilometers from what we targeted. This 10 kilometers is over a distance of 400,000 kilometers. So that's the kind of accuracy what we have achieved. Then, of course, we have to do the orbit changing maneuver. That is, the velocity vector of the spacecraft has to be turned in such a way that it goes around the moon. This, again, we have achieved very successfully. And this event took place on November 8th. And later, we were able to see, once we go to moon, we want to establish our identity permanently. So we carried the Indian national flag on board the spacecraft and an impact probe. That is, you detach a small module from the main spacecraft and allow it to travel to the surface of the moon. So this moon impact probe touched on the surface of the moon on 14 November 2008. That was Pandit Jawaharlal Nehru's birthday on that. And also, it happened to be at a place of very important, the Malapad Mountains. It is one of the critical observing posts for the future. So near to that, we were able to deposit our Indian flag on 14th November 2008. High resolution mapping of the lunar surface has been one of the great achievements of the Chandrayaan mission.
Good morning, everybody. It is my pleasant duty this morning, on behalf of the organizing committee of Sri Srinivas Jyotish Vigyan Research Foundation, to propose the vote of thanks. First and foremost, I would like to thank the Honorable Chief Minister of Karnataka, Sri Yediyurappaji, the State Government of Karnataka, for the benevolent sponsorship and promotion of ancient knowledge system support, without which this historic conference would not have become a reality. I have no words to express our most sincere gratitude to Sri Yediyurappaji, who has blessed us today with his august presence with enthralled us. We are thankful for his inspiring inaugural address. Thank you very much, sir. Thank you very much, sir, for taking time to inaugurate this global conference in spite of your busy schedule and various official commitments. Also, we are grateful to you for your wholehearted support and assistance from various government authorities, including the police. I thank Dr. Madhavan Nair, former Chairman ISRO and former Secretary, Department of Space, Government of India, for delivering the keynote address. Under his leadership, ISRO has made many great achievements, such as moon mission and discovery of water in the moon. Thank you very much, sir, for your enlightening keynote address. I thank all the media and press for highlighting such a great event. I thank one and all, including the volunteers who have contributed the success of this landmark conference. Thank you very much.
I'll confine myself to a few aspects like the structure of the universe, what we know today, and what is the current ideas on the origin of the universe. The constituents, you may be surprised with my statement, it consists of vacuum, space, time, matter, energy, all this leading to formation of planets, stars, clusters of stars, galaxies, clusters of galaxies, and so on. And there are a lot of unknowables still, unknown things and probably unknowables about the universe. You may be surprised with my statement, why do I include vacuum, space and time among the constituents of the universe? The star that exploded that day, today looks like this. This is the picture of what we call the Crab Nebula. This object is very peculiar in that it also has in it other kinds of activity going on. Right in the center where the star exploded is now what is called a neutron star. We normally think it is all matter and radiation, but it's not just that. Actually, the word universe, in its very general implication, has many other things. There is the physical universe, then there is the mental universe, then there is the mathematical universe, and there is a Platonic universe of ideas. And there are so many other things like if you want to bring in universe of gods, angels, demons, and so on. And of course, we also have the universe of dreams. But an important question is whether all these are connected to each other and whether, as the scientists would like it, whether they are all part of what we call the physical universe. Now, for the last several hundred years, ever since man started looking at the sky, we initially had what we call naked eye astronomy. That means you go to a dark place and look at the sky with a good eyesight and a clear dark night when there is no moon. You can see something like 4,000 glittering objects which we call stars. Of course, we are quite familiar with the planets and the moon, as talked about this morning, and the various planets around us, which we knew are moving around. We also became familiar with what we call the micro-universe on the other. Now, on the macro-universe side, as we have already discussed, we have the Earth, Sun, planets, etc., galaxies, then new types of objects like quasars, pulsars, X-ray stars, neutron stars, black holes, etc. Now, black holes was the beginning of new ideas experimentally, which could be discovered with the help of these new astronomers. In fact, the radio astronomers had discovered an object called quasar. The characteristic of quasar was the amount of energy that this star was putting out. Actually, it's not a single star, but a large number of stars together, a galaxy-like thing, is fantastic. You can't imagine, compared to the sun, it is billions of times more energy is coming out from these objects. The question was, what is the source of this energy? Now it is realized, at the center of such objects called the quasars, we have what they are now called active galactic nuclei. What is happening is the black holes are there, giant black holes, not small ones, but huge ones, several times, several hundred times, million times the mass of the sun. And around them, matter is falling, and that is responsible for the release of so much of energy from those objects. As the universe expanded and cooled, matter and force split apart and then split again, still in the first billionth of a second in its history. The universe continued to fragment. Soon, all the constituents of matter, what we now call quarks, leptons, assume separate identities, falling into separate classes that have been joined again. as narrated, the single force, the cataclysm also became fragmented with the new force, splitting away as quark and leptons are formed, and the different particles became associated forever with the new forces that were being created. 3 of the fragmented forces are still working inside the atom. The most powerful of these is the strong force that binds constituents of nucleus together, the quarks that make up the protons and neutrons. 1,000 times weaker is the electromagnetic force that keeps electrons, a type of leptons, orbiting around the nucleus. This force makes atom appear solid and also is responsible for radio and light waves. Another 100 times less powerful is the weak force that causes radioactive decay by the breaking down of neutrons in the atoms of certain elements like uranium. All the forces are transmitted by vector bosons, etc. That recently we recognize that what we really know about the universe is only 4% of what is there in the universe in terms of energy. This is really a very recent finding in the last 10 years or so. Much of the universe is filled with what is called a dark energy. We really don't know still what this dark energy is. And then another 25% of the universe is filled with what is called dark matter. So it's only on the basis of 4% of the matter that we are familiar with here, and which is also, we know for sure, they are there in all the stars and all the objects that we have talked about. The same particles are there, the same costumes are there. But let me tell you, all this observation is based only on 4% of what is there in the universe. We are still ignorant of what the other 96% is, which is filled with dark energy and dark matter. Now, there are now lots of new ideas on what this dark matter is, what this dark energy is, etc.
The truth of the matter, however, is that metaphysics lies beyond common human reasoning, that it has a logic of its own, and that Vedanta is the highest tribute to human intelligence and understanding. Metaphysics deals with a world which Stephen Spender calls a world beyond world. Modern science and technology may and does have their own achievements. They have indeed contributed to the comforts and conveniences of human life, but at the same time they have also caused a good deal of misery in the form of mass killings, mass destructions, and threats of wars in future. Modern science is limited while metaphysics goes without limits, is the integrity of pursuit, the unity of vision, and conception of the continuity of thought process. The very basis of Indian philosophy is one of integration and synthesis between Jiva and Brahma, between Atma and Paramatma.
That staticness can be, lambda term can be replaced with rotation. That is the basic point. Coming to a normal general solution in free space, we never see an object that is not rotating, that is rotating. That means every object is rotating about its axis. So there is no particular reason why it is rotating, but it is accepted one that every object, celestial body is having some rotation. So here, so when